All right, if you're following along, we just made the C-clamp base here, this frame for our C-clamp. Now we're going to look at creating an FEM, a finite element method of the C-clamp itself. So we'll actually run through simulation of the C-clamp being used and see where the stress is developed and where the deflection is as well. To start our FEM, we do want to make sure that we have our file in a specific folder. So we want to create a folder. We can name it C-clamp, whatever you want to name it, because whenever we do the simulation, we are going to actually create quite a few files. So if it's located on like your desktop or something, then you're going to have a few files on the desktop that are generated. It's not the end of the world. You can just move those into a folder later if you want to. But I would recommend that you go ahead and create a whole separate folder. Make sure that you move your C-clamp base part file into that folder, reopen it, and then you can start your FEM. So once you do that and you have your part file opened, we're going to go to Application. Sort of in the center here of our ribbon, we've got Simulation. We have More. We're going to go to More, and we want to go to Design. So Application, Simulation, More, Design. For the most part here, we're just going to take the defaults. So this is a new FEM and simulation. We'll say OK. Solution name, we can just stick with solution 1. We'll create solution. These are changing some of the parameters. We'll just say OK. And we are at a new screen here. And this is us actually in our new simulation where we can go ahead and set up all of our parameters and run our simulation. So we'll sort of move from the left to right here on this top ribbon. The first thing that we're going to do is assign materials. So we'll say assign materials. It's asking us what body to select. We will select our C-clamp base. And this is where we are telling NX what material this is made out of. We're just going to scroll down and choose steel, garden variety steel. So with steel selected, we'll say OK. Now NX knows some of the material properties for our design. So things like modulus of elasticity, for example, now it knows what to apply. Next, we'll move on to this 3D tetrahedral. This is going to be creating the tetrahedral mesh of our part. So again, it's asking for the solid bodies. We'll select this solid body. It's asking for the element size. I'm just going to click on the little lightning bolt here where it says automatic element size. So NX is going to look at what we have and sort of establish what it thinks is the best size. The smaller the element size here, the more elements you'll have. This will give you a more accurate result, but it's going to take longer time to process. So depending on how much time you have, how much processing power you have, you could go smaller here. But for us, we'll just let NX decide on what it thinks is the best size for a good result. So I hit that lightning bolt, automatic element size. Looks like it's telling me it's 0.364. I'll say OK. And it created a mesh for us here. You can sort of see the tetrahedrals and how they're connected. We'll keep going across this ribbon. Next, we have the load type. So load type, we have a few options here. For us, we're just going to use a force. So we're going to think about how this part would actually be used. So we would have the lead screw coming through here, and as we clamp down on something, right? We're essentially pushing up on this surface. So this surface would be moving up, this part would be moving down essentially. So for the force, I'm going to select, it's asking us to select the body focus. So where is the force being focused? I want to select this top boss here. For the force here, we'll say 1,000 pounds. We'll say 1,000 pounds of force. And the vector direction, remember that if we chose this vector direction down, this would be like pulling this part down. That's not what's actually happening. This is being pushed up. So, because we're essentially separating this top from this bottom. That's being separated with the force. So we're going to make sure that our vector direction is going up. And we'll say, okay. You should see on this surface the red arrows that's the force that's being applied. Now, if we look over here to our menu on the side where we have our part navigator, we see some other options here, some other menus that we have. One of them is going to be our simulation navigator. So if we click on simulation navigator, we'll see sort of the file structure here. The file structure can be a little convoluted because we have so many files that are being created here. I want to point out that if we look down, we've got our simulation 1. Now this is where everything's being added in. So right now we've got like the static loads. We have the load 1 or the load that we just added in. That is the force. So if we needed to change that, we could edit that just by clicking on the force. We could also come to our simulation navigator and change that here. So this is our simulation navigator where everything is being added in. And so that is our load. We need to add a constraint. So right now this is just kind of floating in space. It's not being constrained anyway. So we've got our load. Next is our constraint type. And we're just going to do a fixed constraint. We'll do a fixed constraint. And we'll go ahead and just fix this bottom surface here. So we'll select that surface and we'll say, okay. So now we're kind of looking at it like this bottom surface is fixed in space and this top surface is being pushed away. Now this is a simple FEM. So you see there's a few other options here that could be needed depending on what you're looking at. But just for us, we're just doing a simple FEM here where we have a single load, a single constraint. We have assigned material. We've added our 3D tetrahedral mesh. We've added a load. We've added a constraint. So we're ready to actually create a solution for this. So we will go to solve. We'll say okay. It's going to run through and create a solution for us. It says the solution is completed. Do you want to review all messages now? I'll say no. And we can exit out of all these windows that popped up. And in that simulation navigator, you should see results. We'll click on the results or the plus so we can see the structural results. We'll double click on the structural results. Will take us to the post-processing navigator where we can actually see the individual results here. So we can see like the displacement. Now this is exaggerated. Or I should say the visuals are exaggerated. So the colors here obviously correlate to the distance of displacement, but it wouldn't actually look like this. This is an exaggerated result. So let's see what our stress looks. It looks like we have a max stress of 6.83 times 10 to the fourth PSI. So you can see the units here, pounds per square inch, even tells us the max. So that's 68,000 PSI. That's a fair amount of stress. So this would be a good indicator or a way to back up maybe the material that you chose for, this clamp, or some sort of evidence to show why you chose the material that you did, or why you plan on choosing the material that you are choosing. And this might show you that maybe the part needs to be beefed up a little bit. Maybe we need to add some material somewhere, or change the material that we're using, or maybe the forces that we're using are too much, or might change aspects of our part. Now, usually what we want to do is create an image of this. So save this as an image. So visually we want it to look presentable, right? So one thing that we can do is we can move the legend here. We want to make sure that whenever we take an image of this, or screenshot, or a picture, or whatever, we want to include the legend, because if we just have a picture of this, it doesn't really tell us much, right? I guess the areas of emphasis, but doesn't really tell us literally anything. So I want to make sure that the legend is included. What I like to do is make sure that the part is large in the screen. So you don't want something like this, right? But also we don't want to just be so zoomed in that we can't even see what we're looking at. So we want to make it large on the screen. I like to move it over to the right a little bit, because what I'll do is I'll actually move the legend. So we can click and drag this over. We can also change the text size on this. So it's a little small. We can actually right click on it and say increase the size. We can move this over. So we have the legend, we have the image, and we can take a screenshot of this by going to our snipping tool. We can also go to File, Export Image. So that's File, Export Image. The input, you can do graphics area. That's going to essentially take a screenshot of everything that's got the white background here. The format, where you want to save it to, and you can also, if you go down to settings, you can change whether like the background is transparent, or a specific color that you need to have. Because this is, you want to think about whether you're putting this in like a paper, or whether it's a PowerPoint. So like senior project stuff, it's a good idea to have something like this in it. So we want to make sure that we're presenting the material correctly. I'll keep the original background, and I'll go ahead and save this. And here is what the result is. So with something like this, we could then crop this down so that we're only looking at this area. And there's a good image that we could put in a paper or PowerPoint slide, and have something that's presented well. Remember, you could also use the snipping tool for this. So you could use the snipping tool, take a screenshot of that, and have that as well. Both are decent options. For the assignment, you need to create an image of this part and submit this to the Dropbox on Canvas. It does need to look presentable. Okay, it doesn't have to look exactly like this, but it does need to look presentable. You need to show the legend and the part. It can be of the stress or of the displacement.